I will demonstrate a tilt series alignment and reconstruction of a tomogram using the ClusterAlign software. We first need to evaluate the tilt series, so we use image J. Here is a tilt series acquired with serial M, from a thick cryo sample, in a scanning transmission electron microscope. For some reason, during the acquisition, we lost focus and restored it after a time. We wish to analyze the data anyway. The order of the tilt views is from -60 to +60 degrees, in steps of 2 degrees. We observe that the tilt axis is horizontal, so the rotation axis is the x-axis. The fiducials are dark, since it is a bright field image. There are about 40 fiducials in the center projection, and we ignore those particles that enter the screen only at high tilt angles. Now I will estimate the diameter of an average fiducial. The size of the particle is 15 pixels. The size of the image is 2048 by 2048. Now we are ready to start the program. ClusterAlign should be able to align the images in the tilt series to compensate for nanoscale mechanical jitter, introduced during rotation of the sample. We fill out the settings form. Choose the tilt series file in an MRC format. We tell the software that the rotation axis is along the X. The radius of the cluster is half the image size. N cluster is on automatic. Maximum number of fiducials should be twice our estimate. The center slice is chosen automatically. Minimum tracking threshold is 50%. The fiducials are dark and not bright. The average diameter of the fiducial is approximately 14 pixels. Instead of selecting automatic reconstruction, we show alternative way. We can request a standard ALI file generation, but currently we use the default form of just aligned file type. The raw tilt file is a text file containing the tilt angle list, which appears as follows. Then we run the analysis. The software detects the particles and track their locations based on recognition of clusters of points that rotate as rigid bodies. The particles are clustered based on a common height in the sample. The purpose of the cluster recognition is to track individual fiducials reliably. The image in the small window is a template formed from all candidate fiducial particles. The template is used to detect most reliably all the possible particles. On the large window, the detected particles are marked in red. In some projections that are out of focus, the particles are missing, so those images will be ignored in the reconstruction. Rare artifacts will be ignored as well, since only points that appear in specific positions in clusters may be approved as fiducial particles. Now the second iteration starts, and the fiducials are detected with a certain bias based on tracked locations in the first iteration. The tracked fiducials are circled in green. The white circles are the expected locations of fiducial that were not detected in the previous iteration. The output window reports the locations of the fiducials that could be tracked reliably. The list of numbers denotes fiducial identification number, X and Y position in the original projection image, and the slice number. The errors are in terms of RMS deviations of the fiducial locations in comparison to a rigid body model. The image shift corrections are determined from average of all fiducial points, so the alignment accuracy should increase with the root square of the number of tracked fiducials. The performance and the tilt axis orientation are reported. At the end, the just aligned file is being saved, and we wait for the done message to indicate end of process. The RMS deviation from rigid body rotation is indicated in the following text file. The values are ordered according to tilt series views. A -1 indicates that reliable fiducial could not be found in a specific tilt view. Here is the fid.txt file that contains the fiducial locations and can be exported to other software such as iMod and ClusterAlign. We can check the Align Tilt series. We can overlay of the slices based on minimum pixel value to observe the trajectory of the fiducials, and to validate that they follow a straight line. In a standard ALI file, the images will be rotated by 90 degrees and appear with vertical rotation axis. Here the trajectory should be vertical and straight. The output.txt file is a summary of the alignment performance. Here is how I can generate the 3D reconstruction in a customizable way. I copy the last line in the file to the clipboard and paste it to MATLAB. Instead of using default parameters, I will use binning of 2 and number of slices in the reconstruction to be 300. The 3D stack ending with rexcert.mrc can be opened in ImageJ. The brightness and contrast need to be balanced. Further steps to improve the contrast is to make the deconvolution, which shall be explained in another video. A detailed explanation of installation and operation is given in the user manual. The software description can be found in our paper, ClusterAlign, a fiducial tracking and tilt series alignment tool for thick sample tomography. Thank you for watching.